All right, so my name is Zaib, Kaleem. I'm with Access Agility. I've been at Access Agility since 2008, and prior to that, worked for a company called Air Defense. So where are the airtight guys? Anybody here from airtight? No? So Air Defense was a wireless IDS, wireless IPS competitor. They got bought by Motorola back in 2008, and that's when I left them to work for Access Agility. Okay, so my contact info is up there. I work in the Vienna, Virginia area, which is Washington, D.C., and we're very close to, about 10 miles away from Washington, D.C. The goal of this presentation is to talk about throughput testing. Is the mic going in and out, or is it good? Okay. So the goal of this talk is to focus on throughput testing. It's something that everybody talks about in their presentation. We talk about 11AC, we talk about 1300 megabits per second, but how many people actually do throughput testing, right? Raise your hand if you actually do throughput testing. Okay, so that's actually pretty good. So it's a lot of times it's something where people talk about it, but no one actually ever really does any testing either before or after deployment. And I think it's because of maybe the cost or the time it takes to do it, right? So the goal is, how can we get the cost down? And how can we give you tools that are no-cost tools or low-cost tools to do throughput testing? So I mentioned that we're in the DC area, and so a lot of our work is based on trying to win government contracts. And the big challenge of government contracts for any business probably nowadays, if you're an integrator or a consulting company, is the cost, right? So everybody wants Wi-Fi, but when you say it costs $1,000 per AP and then X amount to install it, they realize that that's kind of expensive, right? So what used to be we want Wi-Fi everywhere ends up being we want Wi-Fi in one room or maybe one building, right? So, but when you work in the federal space or the government space, that's the law, right? So when somebody's actually looking at your proposal, the CTO can't decide because I like Aruba or I like Cisco or I like something. They actually go by the lowest priced, technically acceptable solution. And sometimes the vendor names are left off the proposals. So I may give my proposal to the government, they give it to the contracting person, and one person reviews the pricing, one person reviews the technical solution, one person reviews your references, and they come together and they make a selection, right? So we get into this problem a lot in the government space. So everyone knows that Dilbert cartoon about wireless, and it's actually true, right? So we work our butts off. We put together a cool design based on requirements that the government gives us. We integrate it into the existing network based on what they told us they have, Windows XP, tablets, whatever they want to use. We submit the proposal, and we try to price it really low so we can win it, and then we wait. And a lot of times, we get no response, or they lost the funding, right? So the goal is always, how can you build something that meets the requirements exactly to what they want, and how can you keep the price down so that you win the actual work? And sometimes we win the work, and then you have to actually deliver the work, and that's the challenge, right? So you bid something very low to win it, or to meet the requirements at the minimum, so you win it, then how do you actually deliver the solution? And so this talk here can cover many different things, but the focus of this is just the throughput testing, right? So if you look at a typical wireless project plan, either before or after the proposal has been submitted, it probably has some of these components, right? Typically, you review the requirements of what the customer wants, or you review the requirements after you've been brought in to actually do the work. Okay, but the bottom line is you have to know what the requirements are. And with many proposals that we work on, you really don't get detailed information about the requirements. We want Wi-Fi, and we want it everywhere. We want it to be really fast, and we want it to cover every building and every type of device. And so it's very hard to come up with a perfect solution. And typically you start meeting with the vendors either before or after. And the vendors love this part because they get a call from someone and you tell them that we're going to build a network for 1,000 locations. It's going to cover 6 million square feet. And they get really pumped up about coming and meeting with you and giving you loaner gear and demo gear. So it's a very typical scenario that we get into. Towards the middle of this, when we have to let the vendor know that Yes, we're going to build a network for someone, and we're going to submit the proposal, but it's not going to happen for many, many months or years. They tend to get pretty upset, right? So they pull back their loaner gear, and they tend to take away all the cool tools they gave us. And one of the tools that they sometimes let you borrow is maybe throughput testing tools or their other fancy optional licenses. So to get down to the basics of throughput testing, you can still do what you need to do in your test lab with basic tools, okay? Any questions so far? No? During this presentation, if anyone has other ways of doing this or comments, please speak up. I have a lot of slides, but I'm going to try to actually go through them quickly and then do a live demo of IPerf running as on my two laptops here. And if needed, I can show slides of that same thing if I can't do the demo. So the typical solution is much more complex than throughput testing, right? So when you get a requirement from the customer, throughput testing is something that you may do to evaluate vendor products or their capabilities, or to validate that you have the right tools to actually implement the network and validate it. But throughput testing is a very small part of it, and in many times, at least in my experience, it may not be the most important part of it, right? So we tend to focus on throughput a lot in internet articles and on Twitter, but really throughput is a very small part of a true wireless deployment that most people actually want to use, right? So they tend to focus on many more things, manageability, security, but at the same time, throughput is something you have to test before and after. So what someone is looking for is a trusted advisor. I saw an article written by someone either in here or someone else about this, that it's really hard to find a trusted advisor anymore, right? Someone that gives you honest answers about products, honest answers about which ones to select. Should I go with 11 AC today? Should we pull 2 cable runs? There's one okay. There's so many different questions that end users have, that designers have, that it's very difficult to find a honest person or honest broker that can give you the right information. There's a lot of information out there, but there's really nothing like this, right? So if you go to Progressive's website, this is a screenshot from their website where you can type in your location by zip code, probably type in your age, maybe your car type, you're definitely your car type, or probably maybe maybe some other factors about you, and it'll generate a quote. And that quote will give you information on what it costs from them per month or per year for car insurance, and also other people that compete with Progressive. Something like this it's pretty much a marketing tool for Progressive, but you'll never find something like this on a networking company's website, right? They're not going to tell you that, nope, don't buy our product, go buy this other vendor's product, right? So that honest broker concept doesn't exist in networking, at least from my experience. You do have a lot of information out there, and especially regarding throughput and numbers regarding product throughput or overall client throughput for systems that are connected. But you have to be very careful how you actually interpret the data, right? So all the data points out there are pretty good, and I actually like that there's data being generated and content being generated about throughput or about devices. But you have to understand that some of the information that's being presented, it's not presented for you, it's really presented to help the marketing company or to market the company that's actually doing the content generation. So a big example is throughput testing, independent testers or labs, right? It's amazing how October 2013, one vendor wins the competition. November 2013, the other vendor wins the competition. How is that possible? How is it possible that the same company that is doing independent testing tests one vendor in 1 month, and all of a sudden somebody gives them a few $100s to test their product or whatever it costs, and somebody else wins the test, right? So I think the key is that they test in many different ways. They tested using different tools and different techniques, and the outcome is whatever the paying company wants, right? So, and they don't call it winning, they call it maybe verifying or validating or confirming. I'm not sure what all the terminology is, but in the end, if you're paying for it, you're gonna win, and you can publish the results. But it's actually pretty good because this information tells you the best possible number you can get from that vendor. It's like someone's Facebook picture, right? What they look like in LinkedIn or Facebook is probably when they were 20 years old, dark hair, no gray hair, you know, 20 pounds less. It's the best picture of them or the best presentation of what they can do or what they look like, right? Like their resume or whatever. So that's what these tests are. So if you're getting data from the internet, most likely it's probably the best picture or the worst picture of that vendor. And so the worst picture comes from competitors out there, other vendors maybe. So we all know about vendor-on-vendor violence, and either it's anonymous postings or someone that's publicly saying things about other vendors or internet reviewers. So all the data is really good, because when something is really bad, I kind of ignore it. When something is really good, I sometimes question it, but still the data is pretty good. And especially regarding throughput, right? It's all about sort of having someone out there testing and giving you information. That's actually pretty good. The most difficult one in all of these is not the analyst, because you know what they're supposed to do. They're supposed to analyze and give you their opinion, right? It's not the independent testers, because they're getting paid. It's what's called astroturfing. It's like the anonymous slash not really anonymous reviewer or third party that is sort of giving a customer reference maybe, or giving something that's hard to tell. Are they really giving a reference, or are they sort of somehow benefiting from that reference? Those are the tough ones, and it's hard to figure those out, but still that data point about how they use the product or how fast it is or how great it is actually it's good data to have, right? So in the end, you have to design your own network, right? You can't rely on internet postings. You can't rely on a test run by a third party. And it's not that hard to design a network, but you have to design your own network and test it out and see if it actually does what they say it does. And luckily, for wireless, it's not that hard, right? So up here, I have pretty much a full wireless network, right? So I have my MacBook Air over here running IPerf for testing, and that's wired into this Airport Extreme. And I have another PC here, and we have an access point, and this is a full network. And believe it or not, the expert testing companies have this exact same network. It's not any more complicated than this network here. And all they do is swap out the AP with the other AP, and they test it, and they run a real basic test. And it's usually called a high throughput test, which is basically an IPerf test, and it runs as much data as it can through one side, and it measures how much comes out the other side. So it's not that they have more tools or more technology, they just have better writers that write the reports at the end, right? So this is my network here, and some of the tips that I have regarding this network is that you have to do your homework, right? So everyone's talked about training, education, about looking at sort of how to improve yourself on your knowledge, and those are ways to improve what your design is and how you're testing. And in this case here, for wireless, at least for me, I wish I could have attended the previous session where they talked about spectrum analysis and some other things, where in wireless you have to instrument the interfaces somehow, right? So the wired part we pretty much understand, but the wireless part you have to figure out a way to instrument that interface. And in this case here, the interface is in several places, but the main one you care about is, of course, the network interface for throughput testing. You want to have an agent or some type of software on top of the client or the laptop. And then also you need a way to measure the RF somehow. So either the RF energy or the protocol, 802.11 protocol. And those tools are not that expensive, but you really need that when you're doing throughput testing. So the basics or the minimum requirements are you should have a spectrum analyzer, so something basic that if you can find that'd be great, and a Wi-Fi scanner. So if you can't get your hands on a spectrum analyzer, a basic Wi-Fi scanner would meet your requirements. Protocol analyzer would be nice also, right? And then lastly, for throughput testing or application level testing, something to measure throughput or behave like a TCP stream, behave like web traffic, behave like TCP, smaller traffic, maybe telnet or something, right? So luckily, in this conference, we have everything we need. It's pretty cool, right? So we were driving in, I think, was it Sunday night, right? And this is a picture from Eddie. Is Eddie in here? There he is. So Eddie tweeted this picture out, and me and my coworker got excited because it was like, wow, that's a lot of stuff, right? So I immediately started looking at what we were getting. I kind of knew what we were getting, but I didn't really realize it until it was spread out like this on the bed, and the shirt was laid out, and all the APs were shown that we pretty much have everything we need to do a pretty good throughput test, right? So you have your AP, which is the lighting is not that good here. I'm not sure why, but we have the throughput testing with the AP, the Aruba AP 225. We have some spectrum analysis tools, the IPA and is it the MetaGeek Analyzer, and I think there's OmniPeak right here. So I haven't had a chance to install any of these, but I will be when I get back to my work location. And we also have some information about 11AC. So you have your book and a talk on Monday. And there's some other products here. So you have some apps for iOS and macOS. And then there's a site survey software too. So luckily in this conference, we've been given everything we need for throughput testing and for building a test lab network for throughput testing, which is kind of cool. I mean, I've never actually been to a conference where they give this much stuff out. So you build your test network, right? And it's not that hard, actually. And we're not going to get into actually building a network. Everyone can do it here. But the key part is that the network you build should be pretty mobile, right? Because you usually want to be able to take it to maybe the customer environment. You want to take it home to do some testing at home at nighttime when you're maybe studying or trying to do some protocol analysis on the traffic. This is the network I used to prepare this presentation. It's almost the same items I have here. The two items that I don't have here, or several items I don't have here, are the Windows PC running a spectrum analyzer. For my preparation, I used the Air Magnet Spectrum XT product, but now that I have my own license for some other products, I'll use those too. Okay. And then client devices is the most important part out of this testing network that we don't get in our kit, but everyone has a PC, everyone has a MacBook, you probably have 5 tablets and 2 iOS devices or so. Everyone has a client part. So this network is available to everyone based on what we have at this conference and then what you have in your own tool set. The part that you may be missing or you haven't used before is IPerf. So when we talked about throughput testing, how many people use IPerf for throughput testing? Okay. How many people use speedtest.net or some web-based tool? Okay, so that's good too, actually. It's not that bad. So how we got into it, or how I got into IPerf testing or making apps for IPerf, we had a customer project, and for that project, we had to do some throughput testing. And the throughput testing had to be on a iOS device, right? And the customer wanted us to show him or them how fast the device was on the network that we built. So this was back in maybe 2011. And the only option back then was to go to the App Store and to find an app. And there's an app called Wi-Fi Bench. Has anybody ever used Wi-Fi Bench? It's a long time ago, all right? So maybe 2011. So I found the app and tried to download the app, and it wasn't on the App Store. So it was in Google, but not on the App Store. So I searched for who the author was, contacted him and said, you know, what's going on? Your app's not on the App Store anymore. Can I download it somehow or buy the source code so we can compile it? And maybe a few emails, a few Twitter messages later, I found out that he really wasn't interested in putting it back online because it had bugs in it, and he was a very, I guess, sensitive developer and didn't like any negative feedback. So he took it offline. So that's where we started developing tools for iOS testing and macOS testing using IPerf. But in the IPerf world, or any testing world, you always have 2 or 3 items. One is a test console, and that's what you're actually using for testing. And 2 items are the endpoints. One endpoint is the receiving side, other endpoint is the sending side, okay? And in IPerf world, the console is the endpoint. So there are many tools like Ixia or some other higher end tools where the console is a third device, and you use that device for displaying the information, and then you test between the 2 endpoints. In the IPerf world, the IPerf client and the server are pretty much the consoles also. They have the log messages and they have some other tools, but it's actually a pretty cool tool. So what is really IPerf, right? So IPerf 3 is the current version of IPerf, and IPerf 3 is really not the same IPerf that you all probably know. Most people that talk about IPerf or think of IPerf, they're really thinking about what's called IPerf 2, right? So I think what Air Magnet has in their software is IPerf 2. And what most people have in their products is IPerf 2. So some vendors, I think Xeris, maybe Aerohive, I'm not sure if anybody knows, but I think Aerohive has IPerf 2 in their APs. So what IPerf 2 was or is a tool made by a government agency for high throughput testing. And for whatever reason, they stopped developing it because maybe the code base was too complex, or whoever is the main developer left, who knows what happened, and they moved over to something called IPerf, and they renamed that IPerf 3. So IPerf 2, version 2.x sort of stopped, and is now like in maintenance mode or non-develop mode, and all the developers moved on to IPerf 3. And then for a long time, IPerf 3 sort of didn't get developed. It was developed but not really developed. You know, it was maintained but not developed. And then in the last few months, a new person took over, named, I think it's Bruce Ma, and he works at the Energy Sciences Network, and they've been maintaining it for the last few months, developing it, and now it's actually a pretty amazing tool. Some good and bad things about open source software or software that's not commercial software is that it may change. So we took our iOS apps and we based it on something called IPerf 3.0 beta 4, right? And then when this person, Bruce Ma, took over, I'm not sure what they did, but they changed it. So now the latest version is IPerf 3.01, and it doesn't work with our iOS apps, so, which is not good. But you can still download the beta version and compile it, or download the beta version from us and use it with our tools, which is good. Some basic commands for IPerf are, on one side you run the server, and then on the other side you run the client, and you can also control the port number. You can run multiple servers on multiple ports, or you can run multiple clients on multiple interfaces. It's not that complicated, right? And this is basic IPerf 3 that is similar to IPerf 2. But the IPerf 3 folks they're pretty much like really high-end or very high throughput testing engineers. They're testing Energy Sciences Network, which is a 10 gig network or very high-speed network. So they have some pretty cool options that we can take advantage of. And some of those are the -P, right? So when you're testing, TCP has something called, it basically tries to balance out TCP connections. So the idea is that if you have a real lossy network, instead of sending one stream, send two streams, right? And the chance of one stream having corruption or retries may be less than the second stream, and you can improve your throughput. This works very well on wired networks, and it kind of helps in wireless networks, but not too much. What IPerf 3 also has that IPerf 2 doesn't have is the reverse direction test, right? So in wireless, that actually is pretty cool, because when you're going from client to the AP to the wired side, that's actually different behavior in wireless than when you're going from the wired side back through the AP. There's different contention going on. And in the IPerf 2 world, you had to actually sit on the server, run the command, wired to wireless, then you had to move over to the wireless side and run the command, and it's kind of painful, right? So IPerf 3 has a -R, and now you can run the command from the console on the client, test from client to wired, then test from wired back to client from one side, and that's actually pretty cool. You can also do UDP testing, which, I mean, it's not a big deal, but you can do that kind of testing, which is an IPerf 2 feature. But some advanced features in IPerf 3, which is in the latest IPerf 3, is something called the -F, which is a file name test. So this would be similar to what you're doing when you do an HTTP test or a FTP test, where instead of just doing memory-to-memory testing, so when we're using Ixia or using IPerf, you're basically testing from the memory of the device through the network and back to the memory of the device. You're never actually going to the disk, right? So with throughput testing, when we get to 11AC, when you get to maybe 6 gigabits per second or beyond, maybe in the future, the disk may become the limitation, right? So you spend all your time testing the network. Ray, have a comment?
I was going to ask that question because when I've run IPerf in the past, it's RAM to RAM. So, you know, and I think just, I mean, on a smartphone, an AC smartphone, smartphone, can the SSD keep up with what AC can do?
I've never tested it.
Like, is there a way to actually read and write to disk in something like IPerf?
Yeah, so in IPerf, IPerf 3, the previous version, didn't have that feature, but IPerf 3.01 has that feature. So if you compile it for iOS, now you can specify this command and write to the disk from the smart device and read from the disk. And so someone that thinks they have a 11 AC single stream device that can do maybe, who knows, 100 megabits per second, the disk may not be able to keep up with that test. No, I haven't, because I don't have our apps for 3.01. Right, so once we actually recompile that for 3.01, we can do some of that testing, right? That's a pretty cool feature. So now you can actually, if you have a gigabit per second network, you probably won't have any limitations. If you have a multi-gig network, so maybe 2 or 3 or 4, then you want to test your disk I/O against memory-to-memory testing to see if your limitation is your disk, your memory, or the network, right? And most likely you'll find that disks are keeping up with networks, so it's going to always be the network that's the slowest, but you may find out for some smaller devices that your disk is issue. Okay? Creating throughput test cases. This is the hardest part about testing is what are you really going to test, right? We all have great ideas, like what we want to do is we want to test 50 clients, and we want to test an iPhone client and have maybe another Android client and a Mac client and a Windows client to cover every client type. But it's really hard to come up with a good test that you can measure with your tools, right? At the same time, you can actually execute the test. Right? So dreaming of a nice test that covers a scenario that is pretty cool is hard. I mean, it's easy, but actually testing it is much harder. So my recommendation is always create like test cases that you can actually measure with your tools, right? So if you look at those expert testing companies, their tests are always pretty simple. So one of the tests they always run is a throughput test. And that test is as simple as run a script, maybe have the two devices 5 feet away from each other, and it runs a test and reports the results. And that's typically called your range test, right? And they'll actually change the range for one device, so one laptop connecting through one AP, no contention, no multiple clients, nothing special, and they'll test that device again at 30 feet, and then at 75 feet, and 150 feet, and the fastest AP is reported as the best AP out there, and that's all they do, right? So this is a test case that anybody can execute with IPerf, and we can do it here, or we can do it looking at my screenshots. The next test that's a pretty good test is called the client count test, right? So this is typically a test where you fix another metric, but change a different metric. So again, another key to testing is don't change too many metrics, right? So static channels, not auto configuration. Check the config of the vendor. Are they doing something special with either power or something else? But try to make the settings so that you're only changing one metric at a time, and that one metric is something you can measure. Okay, and through this testing process, you always want to maybe do some spectrum analysis before a test and after to make sure it's a fair test for the product and for just for education purposes. Capture some traffic, maybe look at the Wi-Fi scanner results to see some basic RF information, right? So these are probably the two most basic tests that if you actually just run these tests and vary the information, you'll get actually a lot of good results. And in most cases, these are probably the only two tests you need. Now there's authentication, there's captive portals, there's many other things, but for throughput testing, a basic range test for wireless and a client count test for wireless is pretty much all you need, right? So the next step is characterize your network. We talk about wireless all the time, but it could be that your wired network is your limitation, and it could be your tools that are your limitation. So I would spend at least part of my testing the wired network. I was going to do a wired-to-wired test here to show the 941 megabits per second, but I only have one Thunderbolt port, so I can't plug a wired port and show it at the same time. So just trust me that this wired network here can do 941 megabits per second, right? That's what it is. Trust them, yeah. But when you get home, verify it, right? Trust but verify. So from Thunderbolt to Thunderbolt Ethernet, which shouldn't be a problem, 941 megabits per second is what you can max out on this network. So if someone wants to test out maybe a 4-stream Wi-Fi device, it probably won't be able to work because you're limited by your gigabit interface, right? That's your limitation, not the Wi-Fi. Second test is a TCP stream test, multiple TCP stream test. So again, I mentioned this, that TCP has a built-in fairness algorithm, right? And on wired networks, it's really cool because you can actually run multiple streams. So if two people are downloading files on the internet, or two people are downloading Linux ISOs, as somebody mentioned, that each one should get a fair amount of bandwidth, right? And this test here with IPerf 3 is pretty easy. You just specify the -p command, and you do a 3, and that'll run 3 streams. And if you're the only person on that network, it's pretty much 1 stream plus 2 more, and you should get all the bandwidth, right? Now, if you're maybe a third person on the network, and there are 2 other people on the network, they're running 1 stream, you run 3 streams, you're going to get 3/5 of the traffic because TCP will try to balance out those 3 streams, right? So this is what I used to use in college when I was downloading music, right? You had those file download doublers and those other tools, and this is what they were doing. They were sending multiple streams out, and that way you were getting faster downloads compared to your non-techie friends that were waiting for 1 music file to download, right? So, and this should work on wireless too. So if you want to test out a vendor's airtime fairness or some other technology, you can do a multiple stream test and see if they actually can do the same thing over a wired network that the wireless network, the wireless network, that the wired network you can prove does have a fairness portion to it. The next step is maybe some UDP testing, right? So with IPerf, a -u specifying the bandwidth will give you information about loss and jitter and some other things that you actually want to know about. So on the TCP test, our data rate was 941 megabits per second, right? But there probably was some delay that caused that to ramp down or to ramp up based on how TCP works. So even if you send a 100 meg file over this network, which is much lower than the total capacity of the network, something happens, whether it's buffers or something happens that you do get some loss, and TCP can recover, and most UDP apps can recover from this much loss, but you probably want to test, right? That you may have a gig link, and that gig link may only do 600 megabits per second, but is that because of loss or because of some other issues, right? So now if I try to pump it up to the full 900 megabits per second, the loss is still pretty low. Anybody know what is bad for TCP loss-wise? I forget. I think it's like 1%. Is that right? What is it? Any loss. But it can recover from loss, right? Yeah. So the bottom line is that you do have loss even at 900 megabits per second or some issues with the network, and that's why UDP is failing here, right? Something is going on. But it's good to know that, what the numbers are. The next few slides go over the disk read and disk write. I'm not going to do the test because it's not that amazing. It's just basically you specify the server on one side, and then you specify a file name on this side. IPerf 3.01 will read that file and then pump it across the network, and it'll give you the data rate. So you run a disk read upload test, which is like your FTP upload file test. So instead of sitting there doing a FTP movie.file upload and maybe changing the file name for cache issues, movie2 file, you can just do a file test like this and send it.
When I've tested in the past, I mean, you know, if I compared an FTP and the disk wasn't, and maybe the disk was a bottleneck, but you know, there's additional overhead there, so you're never getting the same.
Mm-hmm.
And sometimes, from what I've seen, maybe quite a bit less with an FTP or big download.
Yeah, it's true. So what's happening is that IPerf 3 is really, really efficient, but whoever wrote your FTP program is not that good, right? They're not as good as a pure program that's made to test high throughput. So this tool is made to test gigabits per second easily, and over 10 gig networks and maybe even 100 gig networks. So it's made for testing, and it's really efficient, whereas someone that writes a FTP program may not do all of this, right? That can be done with this tool here. Same thing, do a test where you read from the disk, or I'm sorry, you you write to the disk, right? And end result I found out was that, at least on my network, I'm not disk limited, right? So I wasn't worried about that, but it's cool to show that IPerf 3.01 has that feature now where you can test if you're disk limited or memory limited or write limited or read limited. It's a real small thing, but it's good to have something in your tool where if you ever need to test the 10 gig network, you can do this kind of test, right? Okay, so now we have a summary of our wired network, right? We haven't even tested wireless yet. We have a summary of our wireless network that it can max out the network, 941 megabits per second. Clients are not disk limited. TCP fairness works over wired, so hopefully wireless has some type of fairness too that we can benefit from. The network delay is pretty low, right? And the jitters is not that much. So now I'm gonna give it my official verified logo right there. So I have verified my wired network, and I'll be sending a bill to, where's Keith over here? So this is pretty much what they do. They come up with a basic test, they run a test, and they put a logo on something, and now we're supposed to believe that that product can do that or that that was a good test, right? So now I've verified this network, we can move on to the wireless testing. So back to the training part. You have to know what your maximums are, right? So I don't have to explain this to everyone here, but to start a test and not know what you can do at the physical level, you're not going to be able to trust your test results, right? So now we know what the physical level, the FIDE rates are, and typically the TCP throughput rates are about 60% or whatever the number is, but it's not going to be anywhere close to this number here. And then you have to know your device capability, right? So I have a MacBook Air. I can get up to 8667.7. And then I have some iOS devices, and they have their own data rates. And I didn't verify the numbers for the iOS, so if someone, don't post this thinking this is the actual number, but just verify that. I'm pretty sure that's the max for the iOS devices. And then on my MacBook, I have a wired port, and on my AirPro Extreme, I have a wired port, so I know they can do the 941 that I talked about before. Okay, so now the next step in a good throughput test or a good test plan is to verify what you know already, which is the wired side, and compare the wireless to wired and run that test case 1, which was run a test, move 5 feet away, and do a test again, or move 30 feet away. So I ran a test from my MacBook Air. I think I did this either last night or a few days ago, but we verified what we thought already, and you always should have hypothesis about the results. Like you shouldn't just kind of go into a test just kicking the tires and not really planning for what the results may be. You want to have some idea of what the results possibly are so that you're not shocked by it. At the same time, you can question it if it seems too weird. So I already knew that the results would be around 60% or 50%. So when I got this result back for the 2-stream MacBook Air, I was like, okay, cool, the IPerf is working, and what the vendor told me about their product is correct. It can do the full amount for the TCP through that channel. At the same time, before I ran my test, I did a basic Wi-Fi scanner, signal graph to make sure that there was no major issues with the other interfering devices or RF interference. With the AirMagnet XT, did a analysis of the spectrum, and during the test, after the test, before the test. So usually it's not a big deal, but you always want to test if you're actually trying to evaluate customer or vendor equipment so that it's a fair test to the vendor. You don't want to run one test with interference and one with not interference. Just common sense things, right? And then here's the iPhone, right? So testing the iOS apps is the challenge. So we talked about how I contacted the developer and he took his app down. So our only solution was to make our own app. So most of the apps that we have are for our own purposes, and we sort of repurpose them for the app stores and for other customers and potential customers. So this is me running the same test. It's a throughput test using Wi-Fi perf, which is just our version of IPerf 3. And what we've added on is Bonjour lookup, so I can use Bonjour to find the destination server. And I can confirm if I want to do TCP testing. Megabits per second is what I'm looking at the results. And then I think I have it set to show me results every 5 seconds, run a 30-second test. Yes, this was 1:55 a.m. last night. I remember it now. Don't wait till the last minute to do your presentation. So we're running a test on this iPhone 5S, and it's my iPhone 5S right here, so we can repeat it here, but I don't think we need to, if you see it right there. So we're getting pretty much what we thought we would get, right? So I think I said this iPhone 5 is about 150 megabits per second, so that's about right, 80, 90 megabits per second. Maybe I should have done 100, I'm not sure why it didn't go up to 100, but that's pretty good. And WiFi-Perf has a built-in graph also, so you can sort of share that with someone, screen capture, go back to the test side, and then review the result, and then potentially email it to someone, right? So you click on the email button, and it'll email it out. Any questions about WiFi-Perf? So that's pretty much it, right? So we took a open source product, IPerf 3, compiled it for iOS, and then put a front end on it that was good for throughput testing. And what's nice now by using a open source or a product that you're not customizing is that anyone that has IPerf 3, whether it's on their AP, on their controller, or an IPerf 3 on their Windows machine or on their macOS machine, can test to this iOS device and test from the iOS device, and we don't have to actually worry about that we're somehow manipulating the data or the results are not what you can repeat. So this is what I would call a lab test, right? You would want to give this type of application to an end user. End users typically are not capable of setting up an IPerf server or setting up an environment to do this type of test. This would be a lab test or a field test you would do as an engineer. Another low-cost option for testing that we offer is something called Wi-Fi Medic. This app is like IPerf or IPerf 3, but it has a much more simpler GUI, and it looks like speedtest.net, except that it does some other diagnostics, right? So let's see if I can do a video for this one. So you can test from a web server, any web server out there, or a local web server on your network. And we also run a web server with the app. So I found the web server, which was that IP address on my test network. I ran the test, and it's pretty much getting the same result that we got before, right? So this is a much more basic app that doesn't go out to the internet like speedtest.net would. You can run a local web server on your own network, on your test network, and run a local test. And the file size can be as large as you want. You can make it whatever size you want, but our built-in web server called Wi-Fi Medic server has 5 megs, 10 megs, 100 megs, 1 gig file size. And maybe a tech that installs your APs after you've designed it would run this test and verify that all the settings are correct. He would run a test like you do on a cable tester and email the results to you as the engineer, or the results to someone to accept this install. So email the results, they go to your inbox, you have the IP address, you have the MAC address of what the iOS device is connected to, and you have the throughput results. And that's what Wi-Fi Medic does. I think this test here is an internet test, right? So the first test we did was a local HTTP test. Now, okay, so I emailed the results back. The tech confirms that the local network is pretty high, pretty fast. The next test is click on internet test. So this is your speedtest.net test, right? So I know my local test is 80 megabits per second, but what is my internet speed? So you run the internet speed test, and on the hotel network, that's what I got. So now you have 2 data points that your local network is pretty fast. It's pretty much the max the iOS device can do, but your internet test is the limit on this network, and that's probably what the user experience would be if they were using the internet. There's some other diagnostic tools, simple ping, the gateway tool, and then ping a host. And the way you use those features are, you can program it with your email server or your local router or your local host that you want to test with, and the technician or the engineer can run a test to that, then also email it out. So this result here would get emailed out. You'd have that result too. So now you have ping information to the gateway, ping information to a host on your network, internet results, right, download, and you have local server results. And then the app has a basic diagnostic feature where it does, if you ever use Mac OS or Windows diagnostics, it has a basic diagnostics where it tests to see if you can get to the internet. It does a local gateway test. So we do the same thing with this app.
On the diagnostics, does it actually do a trace route?
It tries to, yeah. So it'll fill on this hotel network, but it tries to, right? And the way we figure out if you're on the internet is it's one hop beyond, I think it's like 2 or 3 hops beyond your local gateway, and we consider that the internet. That should work for most environments. Maybe if you have a multi-hop network, it may not work. But so this would be an app that you would give maybe post-install to a technician or to an end user and say, hey, I can't be there all the time, but run this test once a week. Let me know what's going on. Email me the results, and then I'll come out and do some diagnostics for you.
A lot of times we're finger pointing with the ISP. You know,
Right.
They want to blame the wireless. We're saying it's throughput upstream.
Right. So this would help verify that the Wi-Fi lease is working, right? I think this may not be a video. Okay, so this is a multi. So we talked about test case number 2, which was add multiple clients. So you want to do the range test and the multi-client test. And this test here is the multi-client test. And in IPerf 3, the way that works is, this command is IPerf 3 beta that we have, but IPerf 3.01 can actually label each individual test. Right, and the reason why I had to use IPerf 3 older version is that our iOS hasn't been updated yet, but we will update it. So what you do is you run on my server side, on my wired client side, I run IPerf 3 -C IP address to my, I think I ran it to my MacBook Air. Then I ran a second test to my iPhone 5S. So now I'm running not 2 TCP streams, but 2 separate connections, right? So one connection to one device, one connection to a second device, and this is basically testing what the device count test. So if you remember from the Aruba's presentation, is Chuck here? I don't know if Chuck is here, but so you have, I think, 2 points, right? One is a range test, which is my test case 1, and the second test is a device count test. You can get up to 50 devices, but maybe you can just do 2 or 3 and have a good rule of thumb for the remaining 50 devices that may be on your network, right? So this is IPerf 3 being used to test to multiple devices. And how you test, at least how this setup is set up, is that my wired device was acting as the client, but it's sending through the AP to 2 wireless devices, and that's the way to stress that AP with multiple devices or multiple clients. And with IPerf 3, it doesn't label it, but IPerf 3.01 would actually label it test 1 or session 1, whatever you want the label to be. The command is something like -T, -S, and then S is your label, I think. So IPerf 3.01 would actually label it test or client 1, and you could call that iPhone 5S, and you would call this iPad Retina, and this one here would be called MacBook Air. And this would actually give you the results for the multiple devices. So I think in this one, I show this, but when I actually did the test, I actually did it for 3 devices. This is 3 different devices being run on the network. And your total bandwidth would be the combined bandwidth of all of these. So I think Ixia does this for you, right? But it sort of, Ixia's Chariot product does this for you?
Yeah, most of this
right, automatically. So.
I use IPerf regularly for smaller clients.
Okay.
But by the time you get to 5 or more, it's really hard to coordinate the
Right.
start and stop.
Exactly, right. So this would be your cheap, good, but maybe not fast solution, right? So if you want to save some bucks, this is it right here. Yes?
Is there a reason for the 15 client limit?
On IPerf 3? I haven't tested up to 15 yet, no. Is that for 3.01? Okay, no, I haven't tested that yet, so that's new information for me. It's a 15 limit. I'm not sure. What you can do is to get beyond that, you can just run a separate IPerf -S server, right? So port 5000 is 1, port 5001 is 2, port 5003. There's really no limit to it, it's just probably the interface they've done. Maybe they're counters for how they do the counters. Maybe they're best practices for testing over high speed. But there are ways, even to do this test here, you don't have to use this command. You can just run IPerf -S on 5001, -S on 5002, and run your clients on the same port. So this command here helps, but it's not required for that type of testing. It's just easier to do it this way versus actually running separate ports.
Have you studied the effect of running multiple streams?
One client with multiple streams? No, not too much. Right, so
I came in with window sizes.
modifying window sizes?
Yeah, changing TCP window sizes in that IPerf config.
I don't think it should be a problem because typically, I don't know if you have a lot of data points on it, but at least on Mac OS and some other platforms, they're pretty good about their window size. Like automatic window sizing is probably better than setting it to like a fixed 64 or some higher number.
Yeah, so just a suggestion for follow-up. So typically, I mean, what we find with both IPerf and Chariot is one stream tends to not be enough to fully drive the channel with a single client.
Right.
So the best practice, and I think this most of the vendors do this, would be 4 streams. 4 streams is kind of the sweet spot.
Right.
It depends on whether it's AC or ag,
Right.
and what the channel width is. But I think you'll find that you actually get more in the same device if you run 2 streams.
Right, yeah, exactly. Yes.
Which indicates that there's bottlenecking going on the stack.
Right.
And then you typically can drive the TCP numbers higher by increasing the window size as well. We usually run, I think 1024. Dash W 1024.
1024, right. So 5 minutes. So pretty much all the basic rules for TCP apply, right, over wireless. The actual fairness issues may be different based on how the wireless product is doing it, but the actual way TCP works applies in changing window size, MTU size for UDP, all those things that you would probably test on your wired side first and then see how that impacts the wireless, how you want to do it. So like if I were to test, I wouldn't actually make that change on the wireless only. I would test it on the wired and verify what the behavior is, and then do it on the wireless to see how that actually benefits or hurts the wireless side. Okay, so I've got some numbers from the Aruba testing, and so the idea was that I would verify these numbers using IPerf 3 and maybe even show how much longer it takes or how long it takes to get these results in IPerf 3, and then also take your feedback about changing window size and trying to push it to higher data rates and do that. But the idea is that it's really not a magical test, right? So one is a range test and one is a count test, and you pretty much have all the tools you need to do that testing. So if you were to see a report from any vendor or any third-party company, within maybe half a day you should be able to verify those numbers if you have the equipment. It shouldn't be that complicated. So instead of just saying, it's not true, it probably is true, it's just how they tested is what they're telling you, not that the app or the product is doing something amazing, it's that they tested a certain way and that's what the results are. So again, I work for Access Agility, and these are our apps. We're updating these apps for IPerf 3.01. We also have another app called ZapPerf. Any Ruckus people here? Ruckus? Ruckus. Oh, question. Okay. Oh, Ruckus. No? Sorry. Oh, client. Okay. So Ruckus has something called Zap Wireless. We're trying to figure out exactly how Zap Wireless works to see if it makes any different types of, if it somehow gives you different results on a network. What I've seen is that sometimes when I test Zap on a 1 gig wired network, I get 1300 megabits per second. And I'm not sure like how to explain that, right? So I don't feel comfortable using it all the time, but it does give you higher numbers somehow. But then when you test it again over a lower speed network like wireless, you get what you expect, like 547. But how can I explain that 547, at least to myself, is accurate if the wired test is pushing to 1300 megabits per second, right? So, but we have this app on the App Store, and we're updating it to make it a little bit more iOS 7 looking. But once I get more comfortable with how ZapPerf works, or Zap works, I'll probably use it more.
I know you've been asked before, but are you likely to develop any Android?
Yeah, so all these apps have Android versions.
Oh, are they?
Yeah, yes.
Because I think originally they were just doing iOS.
Yeah, I mean, it's...
I guess on the iPhone you need something, right? Because we've got all the other apps on the Android. So
Yeah.
But it is good to have something.
I was going to try to show our, show the new, let me see if I can get on the network. Okay, so the best practices, so down to the last slide, then maybe I can do a quick demo. So throughput testing is free or low cost, right? So IPerf from the internet is $0. If you go to our company website, you can download the 3.0 beta 4 version, which is compatible with our apps. And we'll be posting the 3.01 compiled for Mac OS soon. which I used for my testing, and then also post the 3.01 compiled for Windows. So everyone should have access to a Windows version for the latest version, and a version that can work with our apps today, which is a beta version. The best practices, in addition to some of the tweaks that we learned about today, are characterize your wired network first, right? If you don't understand your wired network, then you're probably going to make a mistake in the wireless side. Characterize your access points, which would be the throughput testing. Maybe their gigabit port, is it capable of pushing a gigabit? Characterize your clients, and then change only one item at a time. So measure only one metric. You don't want to measure airtime fairness and client count. You don't want to measure multiple streams and something else. You want to change one metric and verify that metric with an assumption or with an hypothesis of what you'll get as a result, and then look at the results. And the last one, which is an expensive one, but for wireless it's a must-have, is instrument the interfaces. So your protocol analyzers, your spectrum analyzers, Wi-Fi scanner, which is a low-budget RF diagnostic tool. And then lastly, in the field, you want to have a tool to verify the information also. You can't rely on sending an engineer to the field, right? So a real low-cost app, maybe even Ping, maybe even speedtest.net, maybe even something that you can call someone or email them, have them test something, send you the results, and you can make a decision on what could be the problem, right? And then I think that's it.